Welcome back everyone. So in today's video I'll be showing you how to use Apache Airflow to orchestrate an end-to-end ETL pipeline. Okay, so let's get to it. Okay, so like I mentioned, in today's video I will be showing you how to use Apache Airflow to orchestrate an end-to-end ETL pipeline. Okay, so in this video we will actually only be focusing on the ingestion piece of ETL pipeline. So remember, ETL stands for extract, load, and transform. So actually it's two pieces on this. So we are going to be extracting the data and loading it to Redshift, and then in the coming video I will be showing you how to use dbt to transform the data once we have the data loaded to Redshift. Okay, so we will be going through the ingestion, basically extracting the data, and in this case we will be using Python to simulate data generation, and then we will load that data to Amazon S3, and then from there we will also go ahead and load it to Redshift. Okay, now in the next coming video I will be showing you how to pick the data from Redshift and transform that data. Okay, and we will be leveraging dbt for that. Alright, so again in this video I'll be showing you how to ingest the data, load it to your data warehouse, and we will be using Apache Airflow to orchestrate this process. Alright, so let's go ahead and set our environment so you can see the pieces that we need for this video. We do definitely need to have Python installed, and we need our AWS account set up, and we also need Apache Airflow to be running. Okay, so I will be starting with AWS, so I'm going to log into my AWS. So if you don't have an account with AWS, you can go ahead and sign up. I think you do get a free credit for about 1 year. And then once you sign on, go ahead and log in. So I am logged in here, and basically the first thing that we need to do, I'm actually going to start, you can start with any of them, but I'm going to start with S3. And so I'm going to go to S3. What we want to do here is to create a packet where we will be extracting our data to. Okay, so I have a folder here, or a packet here created. You can just go ahead and create a packet here, put a unique name, and then just go ahead and create it. It has to be a unique name. I already have the packet created, so I will go inside this packet. I have another subfolder here created where I will be putting my data, so called incoming data, and here I have a number of specific files here, and for this one I have orders. So inside orders I will be putting orders. Now in this case we will be creating a Python code that will be simulating order generation or orders. Basically it's going to create fake order data, and then we'll put here. Now this doesn't have to be, you don't have to follow exactly the same process. You can basically use a CSV, but in this case I just want to show you, say in a real world scenario where you are ingesting data from either third party or from APIs. How will you go about that? Okay, so then you will have to have some code basically that either is bringing data or some sort of a process, an ETL process. Could be like a tool like Talent or anything that brings your data to S3. Okay, so in this case we'll be using Python. So the Python code will be generating the data, and it's going to be landing it in this folder here. And then from here we will also have a script that is copying the data from here to Redshift. Okay, so let's go over to Redshift now. So this is my Redshift warehouse. You can just type Redshift right here if you want to search for Redshift, and then just go ahead and open it. Now for this case I do have Redshift serverless, and I have previously made videos where I went through the process of creating and provisioning Redshift serverless. So do take a look into those videos. I'll put the link in the description, and then once you have that, you will probably have something similar to this. So from here all you have to do is just go ahead and go to your query editor. Now with serverless you can actually query your data directly from here in the browser, but you can also connect to client tools. So I also did a video where I went through the process of connecting your Redshift to a tool like dpfer. So if you are comfortable using client tools, then you can go ahead and connect it to a tool like dpfer. But I'm going to query this in the browser, so I'm just going to open this query editor version 2, and so this is now the dashboard, this is how the dashboard looks like. By default, it's going to open where I left it last time. So basically, this is your serverless account. So if you expand this, you will see, I think you will see these two: native database and external database. And then so native database is the databases that you will be creating, and then external one is where your data is sitting externally outside Redshift. Okay, so here we need to create a database. I think by default the dev account comes with the Redshift. So when you create it the first time, you'll get the dev account. So you will get a dev database. Okay, so dev database comes by default. So because we are ingesting this data from S3, what I will do in this case is create another database. So we'll be creating a database called staging in this case. You can name it any name, as you know, that suits you, right? So we'll go ahead and create database. I already created it, so just go ahead and you can create database staging. This is a script, or that's a command for that. And then after that, what I will do is create a table. Okay, so this table is going to be holding the fields for the file that we are going to be ingesting. Okay, so we have order ID, custom ID, order date, status, product, quantity, price, and all of this, right? So I will go ahead and create this table inside staging. So I have to switch over to staging here, like so. Okay, so we are going to create a table called staging, and if you go to this database now, you will not have a table here. Okay, so if you have an existing database, you will probably have some tables. Then you can just go ahead and leverage that. Okay, so I'm going to create this table now called stg orders. Okay, I'm just going to execute it here. Okay, so the table has been created now, and if you refresh this staging database, we should have a table created now, right? There we go. Okay, so we have one table created here called staging orders, and it has the fields that we specified. This table currently does not have data, so if you just go ahead and right click and select, you will see that this one is empty. Okay, so this is empty. So what we'll do is so basically now we have our Redshift table created, and we have our bucket here created. So we are done setting up the things on the AWS side. Okay, so let's go ahead now and switch over to the generation of the code. Okay, so we will be writing a Python code that will be landing the data again to S3, and then we will push that data from S3 to Redshift. Now for that piece, we will be doing all of that within Airflow, because Airflow is written in Python. So, and again, in this case, we are using a Python code that is going to generate the data. Then we'll just do everything in Airflow. Okay, so we'll just write a DAG that will have a Python code, and that code is going to generate the data. And so every time we run the DAG, then the Python code will always be pushing the data to S3. And we will also include the piece in the DAG, or the Airflow DAG. Will include the piece that is going to be copying the data from AWS, from S3 to Redshift. Okay, so let's go ahead and do that. So I'm going to go over now to my Docker environment, make sure that my Docker is running. So this is Docker desktop, and the reason I have Docker desktop is this is where I have my Airflow installed. Okay, so if you have watched the previous videos that I made 2 videos. The first one was basically I made 2 videos on how to run Airflow, right? So the first one was using Python virtual environment. That one works fine, but I found out that in some cases, if you don't have enough resources in your computer, you might run into issues. Let's say you are ingesting data from APIs and whatnot. The Python virtual environment, the Airflow running on Python virtual environment might not always work as you desire. So I found out that the Airflow running on Docker is much more efficient, and it's going to work pretty faster than if you were going to use the Python virtual environment. And also the good thing with Docker is once you have the compose file created where you have your airflow specifications in it, then all you have to do is basically just do docker compose, and it's going to put up your airflow. And the next, and when you're done with it, just shut it down. Just do docker compose down, and it's going to clean up all the resources. So we will be using docker. Okay, so I have docker here, and then again, docker, how to install docker on your Mac environment and how to set up airflow on it. I already did the videos for that, so I will put the links for those as well in the description. Go check them out. Okay, so now that I have my docker desktop here, what I will need to do is basically now go over to I will actually go to Visual Studio Code here. And what I will do here in Visual Studio Code, because when I installed Airflow that runs on Docker, I created a file on my Explorer, Workspace Explorer here. This is the one, Airflow Docker. I created this, so if you watch that video, you'll have seen this. I'm basically leveraging the same folder, the same process that I used in that video. And then I'm just going to open it here. So if you open it, you will see it right here in Visual Studio Code. So I have, since then I have added some files here, and I've also added the file that we'll be using in this video under DAX right here. So this is my folder structure for Airflow, right? Airflow that's running on Docker. So you have the config here, you have DAX, you have logs, you have plugins, and the most important one here is the docker compose file. Okay, so I'm just going to quickly walk you through this docker compose file. Okay, so this docker compose file, again, I added this file when I was making the video where I went through how you can run Airflow on Docker. Okay, so all of this I did it previously. So this is how the compose environment or compose file looks like. So you have your services running on PostgreSQL, and these are the login information here, right? So the username is Airflow, and the password is Airflow. The database here is Airflow. So this will be holding the metadata, and so this we just copied this directly from the compose file, and then it's going to be running Redis. This is your web server, all of this, right? So I worked through all of this in the last video. I'm not going to cover it now. So this is how your compose environment looks like. Now, the two additional things that I've added here is the requirements file, right? So because we will be running Python within the Airflow environment, there are some libraries that we might need to use in order to run our code properly. And one of those libraries that I found useful is Feka library, okay? Because we will be using Feka to generate our data, right? So if you don't install this in your Airflow environment, then when you run the code, it's going to complain that it's not able to find your Feka library. So one way of, I think there's several ways that you can include this in your environment, but one way, if you're running on Compose, is to add it to your Compose file. So if you go, so I have my requirements file here now within the same structure, right? So I'm just going to Compose file here, and under volumes I have added, or basically mounted, the requirements file. So this is how I've done that. So I just copied one of this line, put it here, put like the requirements.txt, and we are mounting it to Airflow, this section here. So the opt Airflow is basically the file in Airflow, which is on Docker, right? So this is basically your Docker file. So we're basically pushing it to Docker environment under this in this location, right? And then the other thing that you may need to do, so that when your Docker runs, it's going to install these libraries. Under pip additional requirements, you need to add the libraries that you want installed. So in this case, I've added two of them actually. I've added dpt, maybe this one was there, but I've added dpt, and actually I think this one was there. I don't remember adding this. I might have added it, but the one for dpt Airflow is this one, Airflow dpt. So this one, because again we'll be running it next, and I will walk you again through this file the next video when we go through how to run dbt in Airflow. So you do need to install this is basically going to allow you to run dbt commands in Airflow. So this is going to allow you to it has the operators for dbt, for running dbt on Airflow. Okay, so Airflow dbt has all the operators that will enable you to simulate dbt. So you can have you will have like an operator that you can just configure, and it's going to run dbt code for you. So that way you don't have to use the bash operator, right? Anyway, we will do this later when I do that video. But the one I wanted to show you is this one for Feka. So you need to put the library here, Feka, and then that's it. That's pretty much it. So if let's say later we run and then we face an issue, then we can install. We can just put it there. So let's say pandas here. If we run our DAG and pandas complains and not able to find it, then we'll just put it next here like this. Like so, right? There we go. Okay, so this is the compose file, and this is my requirements file, and inside here we have the DAGs. So I will come back to this once we start our Airflow environment. Okay, so we have our DAG file here, and the one we are using is this one for Redshift. So I'll come back to this Redshift file here. So for now, let's go ahead and put up our Airflow environment. So I'm going to actually run this in terminal. So I'm going to terminal, and clear. I'm going to clear this, and I will increase the screen size for this. Okay, so what we need to do is we need to go to that location. So I have it, I think it's under repos, and we want to go to, maybe it's not there. I think I might have it right here. Okay, I have it up there. So we'll just go to that file, Airflow Docker. There we go. Okay, so we want to go to where our compose file is, right? So because we will be running it using compose. So if you list this, we will see the Docker compose file now. So this is the same, it's basically the same directory that I had in Visual Studio Code. So from here, to start your your Docker environment now that will have your Airflow and everything, all you have to do is just do Docker compose and up. Okay, so this is going to basically go through your Docker compose file and start and create the services that was specified there, and mostly the services that we had in that compose file are Airflow related. So it's going to go through that file, and it's going to start the Docker environment and the Airflow environment as well. So you can see now we have you can see from the logs, right, we are installing the dbt. So we had dbt cloud there, which is what we had in the additional pip directory. Okay, and I think also up here it will have gone through the dbt, I believe, even the Feka one as well, and the Airflow dbt. So yeah, you can go through the logs. It will install everything that needs to be installed, and at the bottom, if we don't have any error, at the bottom here it is going to show you if all is good. So you can see here there might be some warnings and all, but looks like once you see this one, you see get health, HTTP and all of this, I think it looks like it's running, state running, queued and all of this. Okay, so I think our Airflow environment should be up now. So to do that, just go to localhost 8080, and we said the username was Airflow and the password is Airflow as well. Of course, you can change that if you need. Okay, so we are able to log in now to our Airflow environment. This is how the Airflow dashboard looks like, and we do have a number of DAGs that are not started. So these are post, and then there's one that is running. Okay, so if you see the one that's active here, this is the one for that Redshift. Yeah, this is here because I was going through it before. So I'm going to go into this, and what I will do here is, yeah, I think it's not running. Okay, good. So this is how the DAG looks like. So I'm just going to probably unpost this, like post this, and what I will do is we go back to our Visual Studio Code now, and I will walk you through what the code is doing. Okay, so again, this is our DAG that we'll be using in this video, and we'll be using it to orchestrate data coming from Python, generate data going to S3, and we'll load the data to Redshift. Okay, so the first piece here that we're doing here is basically we are importing the operators we'll be using in this DAG. So you can see we are using Python operator. We are also using S3 to Redshift operator. So this is going to basically copy the data from S3 to Redshift. I have added here dbt run operator. This is the one that we will have used if we were going to run dbt, but in this case I'm not going to use dbt. We'll do it in the next video. And then we have S3 hook to let us connect to S3, and we have some dummy operators to just basically help us structure well our DAGs. Okay, and then for the Python piece, we are using pandas and the Faker library to generate data, and some other additional libraries here for our code. Okay, so let's quickly walk through this, and I'm going to I'm going to put this code in my GitHub if you don't want to copy. Okay, so you can just go to the GitHub account and basically copy it from there. So what I'm doing up here is basically getting the creating variables here to point to our Redshift environment, to our AWS resources that we'll be using. So in this case, this is a S3 packet. I showed you that. In Redshift, we'll be using public schema, but you can also create another schema for yourself. Let's say orders or whatever, whatever fits your use case. You don't have to use a public one. And then the name of the table, the name of the staging table. So that's the one we used. We created this table called stg orders in Redshift, and so I didn't include the rest of these ones. It's dbt related. Now right here, you do need an IAM role. Okay, so this one step I skipped. We need an IAM role, and this IAM role we will be using it. Let me see actually if we're using it in this case, because there are two cases where you need the IAM role. Okay, so I'm not using it, and the reason for that is because I have the connections to AWS created. So but yeah, so I created an IAM role in case you go ahead with IAM role. Basically with IAM role, you can use that to give permissions, so that say you want to copy data from S3 to Redshift, then you create an IAM role that will have access to S3 and Redshift as well. Okay, so I'm basically going to comment this out. We are not using it in this video. Okay, these are the default documents, and then we have the Faker library here. And so this piece now, we are going to be using this code to generate data. If this code looks familiar, then it is familiar, because in one of the previous videos, I used this code to generate data for Snowflake. Okay, so I basically just reuse the same. I'm reusing the same code because, why not, right? So this code is simulating generation of CDC data, change data capture. So, and what it's basically doing is it's getting, it's simulating a order table that has order ID, custom ID, order date, and kind of just faking it, right? And what it's doing is, like for example, you have the status, created date, just putting the fake status dates on how your data will be looking like, including the change time. Okay, so CDC time some here. All right, so it's going to generate 500 records, and what it's basically doing for the order ID is going to start from 0 going up to, let's say in this case, 500. Okay, so that's why I'm incrementing it every time it runs, right? It's also going to calculate the price here for a quantity. So sorry, the total amount is going to, so a field, a field called total amount will be created. I don't know if I have it here. No, but this field will be created, and it will have this is the calculation, right? We are using quantity times price, right? And we are going to get a total quantity for that, and we are going to append it. So this is also a field that will be present on this data. We are running it, we are storing it as a data frame, and then from here we are uploading it to S3. Okay, so this is the Python function doing that, basically getting the packet name and the file name and the data frame, which is what we have right here. We are using S3 hook to connect to S3, and now right here you will have AWS connection, and the connection here, you might be wondering how it's getting this connection ID. This one I have defined it and created it in Airflow UI. Okay, so if you go to Airflow UI, you go to connections, where is it? Connections, right here. Right here. Okay, so you will have the, I've created a AWS default here, and basically what this one is doing is, if I go here, I have my access key, and also the secret access key. So what happens is, for you can actually use this, or you use a role. So there are two ways again. You can use the credentials, or you can use AWS role to connect to your AWS. So in this case, I'm using the credentials. So you get this information when you create a user. If you create a user in AWS, you can go ahead and generate access key and secret access key for that user. And that is the information I'm using here, right? So this is the access key that I'm for that user. For the secret access key, it's not showing here, but it will be looking like something like this, okay? So I'm putting that information here. If you're using the same thing, yeah, just you can bring the access key, put it here, and then put the secret access key here, and go ahead and save. You can put the connection ID here. You can name it whichever way. So for this case, I'm just naming that AWS default. Okay, and now if we go back to the code here, that is the connection that we are using here. So that's basically, this step here is going to use that information in order to connect to our S3 and write the data there, because Airflow has to know, or Python has to know, how to connect to S3 in order to extract and load that file, right? And then we are just going to basically we are loading the data into S3 as CSV. So this step, we are basically converting the data frame to CSV, and we are just doing some additional conversions here, right? Like we are loading into string, because this will be string, and we are basically converting our data frame into a CSV file. Okay, and once we have converted our data frame to CSV, we'll go ahead and upload it, and once it is uploaded, we will print a message saying this data was successfully uploaded to our packet, and we'll print the packet here. Okay, and then so the last step here now is basically the function that will be doing the actual work for calling this method here, or function here, to load the data to S3, right? So what we are doing here is we are going to be calling generate CDC, right? So in this step here, this last step here, what we are basically doing is we are creating a variable here, and this is going to call the function to generate the CDC data, which is what we have right here. This one we put it as 500, but we are overriding here. We are overriding in this step, and therefore we are just going to generate 20 records for this case. Okay, so and then we go here, we want to define the S3 packet and the file path. So this is a location, this is the file name that we'll be using. So we are inside our CK data deck. We want to go to incoming data, which is the other additional subfolder. We'll go to the orders. We want to write this to the orders folder, and then also then we will name the file name like this. Okay, so we'll name the file name CDC order data, and then we will also append the date, basically the timestamp, when this pipeline runs. We'll append the timestamp to this file. So when we run our code, then you will see a file in S3 that is named like the CDC order data, and then it also has the timestamp when that file was written. Okay, and then basically we are just calling the method here to upload, which is what is happening right here. Okay, it's uploading, calling that file, and we're passing the S3 packet name and then the file name. So S3 packet name we already defined up here. It's getting from there. The file name is what we have here, and then the CDC data that we want to load is what we have here. So in this case, 20 records, and we are loading it to S3. Okay, so the order of events, you will have the 20 records generated. It will be passed to this function here, and this function is going to convert the data frame to a CSV file, and then that CSV file is going to be loaded in S3 or to S3 in this format right here. Okay, very good. And now we have our basically we are returning it. So we return the file name so that this function can run. And now this is now the main part of the DAC. We're basically starting our DAC, and we are naming it Redshift end-to-end pipeline. I will change this name, and I will say end-to-end. I will just basically say extract. Let's say extract and load data to Redshift. It's long, but it makes sense. Extract and load data to Redshift. Okay, so this one is going to extract the data, put it to S3, and then eventually load it to Redshift. Of course, this is a very basic DAG. You know, we don't have a lot of information here. We didn't put retries, failures, notification, and all of that. There's a lot that you can do with Airflow. We are not doing the course for Airflow right now. I'm just showing you a bare bone skeleton. But so this is what we have. We are not catching up, and our interval currently is set to daily. Also, I have this damming operator. This doesn't do anything. It's basically signaling. We are going to use this letter to signal that we want to start our DAC, and then once it's done running, we'll just put this end here to signal that it's done, or that's the end of our task flow. And now the first task that we are going to be running here is this one for generate data. We are going to be now running the Python operator. And the Python operator that we are calling here is generate and upload data to S3, which is this one right here. So we will call that Python, and when that happens, basically it's going to call that Python function, and it's going to run that Python function. That Python function is going to generate the data and upload it to S3. That's what's happening right here. So basically we're extracting our data and loading it to S3. Now the next thing that will happen now after we load that data to S3 is we want to copy that data over to Redshift. Okay, and we are doing this in the same DAC, right? We load the data to S3, and then right after the data is there, we will copy it to Redshift, and we will be using this Redshift S3 to Redshift operator. Okay, and now I'm naming this task ID copy to Redshift. And now we have to specify our Redshift information. So like the schema here, we are using the Redshift schema. We already we already did that one right up here. Okay, so the schema is public, and then what is the next one here? The table is Redshift staging table. Okay, Redshift staging table, which is right here. Now you might be wondering, okay, where is the database? How does it know which database to write to? Which is a great question, right? And for that information, we have put the information for that one inside this Redshift Con ID. Okay, so this Redshift Con ID is also another connection that I created in Airflow UI that is connecting to Redshift. And for that, we'll go over again to our Airflow UI. Just go to connections and just go ahead and create it. So in this case, I have created this connection here. I've named this Redshift Con. The connection type is Amazon Redshift, and this is my sandbox. It's my sandbox server, and this is my database, which is staging, right? So we are writing to staging, and my username is admin, I didn't specify, I didn't put the password here. Okay, so so you put all of this information here and then the port number, and then just go ahead and save it, and it is going to save your information. All right, so now that we have this, let's go back now to our DAC right here. Okay, and what you want to do here is, now in your Redshift Con ID, we are putting the connections to Redshift, and this variable is basically coming from our Airflow UI. So this is the name that you put for your connection ID. This is the one I was just showing you. How you named it, you put it right here. This is your Airflow connection ID for Redshift. There we go. And then also, because for AWS, like for this one, we are not using a role, right? So I ran into an issue here when I used Con ID, connection ID here. What you want to do, and you used Airflow here, then you don't have to call the IAM role down here. Okay, so you can actually basically, and this is optional, I believe. I don't think this one is required. This is again only good for S3, so I don't think you need this one here. And then, so the copy options that we have here, this is basically how your CSV file looks like, right? Or how your file in S3 is located. So if it's a Packet file, then you put the copy options right here. So in this case, we are specifying that the file format is CSV. We are ignoring the header because we already have the table created in Redshift, and that's pretty much it. So you might be tempted to put the IAM role here, and what I found out was that if you're using, because this will be the IAM role that will be used to copy your data right to Redshift, but you already have the connection to Redshift here, so then you don't need this. Okay, so it's going to clash if you put both of this. But if you use IAM role in both of this, the connection ID and all of this, then you will just need to put that one right here. Okay. And finally, we are basically executing our DAC. So these are the task dependencies. We are starting here. So we are doing the start. So we are putting the start task here, which is the dummy operator that we have right here. And then the end is also here. So we are then, okay, so we are starting our DAC, and then basically we are running this sequentially. So we'll start with start, and then the generate data task is going to generate our data, and then upload it to S3, I believe. Yes. So this is going to generate our data. This is a Python code that generates our data and uploads to S3. So we are putting it here. And then next thing is we copy that data from S3 to Redshift, and then we are basically ending our DAC right here. Okay, so this is pretty basic, and this is all we have to do in this case. Okay, so we have gone through everything. So I've walked you through what this DAC is doing. Again, it's generating the data. We are using Python code to generate the data, pushing it to S3, and let me show you in S3 where that data is going to go to. Okay, so we have our folder here. It's going to go to incoming, and under orders we will have the file here. Okay, so I'm just going to delete this so that we don't have any file there. Then I will show you when we run it from scratch. Okay, all right, so this order location is pretty clean. We don't have anything. Now let's go ahead now and okay, so before we run it, so that's the beast, that's what's happening there. And then so we are in our main DAC, we are basically calling the Python function that is generating the data, and then we are leveraging S3 to Redshift operator. This is a Airflow operator that is similar to copy. So this will be similar to, say, if you were to do copy into the Redshift table, and then using whichever IAM role, and then you specify the location of where the data is coming from. Okay, so this is the equivalent of that. We are basically just calling this operator. It's going to be doing pretty much the same function. And then finally, we are basically just ordering it so that it can basically specifying the task. So of course, what's happening here is we want to generate the data before we upload. So that's what's happening here. So this is going to run fast, and then the next one is going to generate the data, and then after that it's going to copy the data. So you cannot run this in parallel. So these have to be happening sequentially. The data has to be available before you copy. Okay. All right. So I'm going to save this. Command save, or you can just go ahead and file and save. That's going to save the file. And now once you save it, if this DAG looks good, we should be able to see it in our UI. Okay. So we'll go here. Okay, so it was 78. I don't know if you saw that. Now it's 79. Great. And you can scroll down, but the easier way of looking, if you have a lot of DAGs, the easiest way to find your DAG is through the ID. Okay, so if you come here, this is the ID. This is the DAG ID. So if you just copy this, and now you bring it here, search DAGs, paste it right there. And there we go. Okay, so you will see it right there. Just select it. And so this one has never run before. This is the first time we'll be running it. And now it's post. When it's created, it's post. And now to run this, all you have to do is just unpause it. Just click this icon here to unpause it. It's going to unpause it. I don't know if it's going to run immediately after we... Yeah, there we go. Okay, so it did. And you can see that one is pretty easy, right? I don't know if you saw that, but it basically, after we turned it on, it went ahead and ran our code very fast, and we didn't see any error, so everything succeeded. So that is pretty good. So it started, went ahead and generated the data, and you can see the logs here. You can see the logs from here. You can see data uploaded to S3, and this is the name of the file with today's date. And that is pretty good. Okay, it went ahead and also, I believe, copied it. Okay, no, that's not the one for copy. It's the one for copy, the second one here. Okay, so right, yeah, so you can see in the logs here, you will see what's happening. So it's basically the copy, the S3 to Redshift copy operator, right? Is basically using this kind of copy. It's copy the data to public to STG, right, from this location using the credentials that we specified, and the first one is the header, and are doing all of that. Okay, so this is the operator that's using S3 to Redshift. Lovely. Okay, so you can see this DAG now ran successfully, and of course you can also see the code here. If you go to the code section of the DAG, you'll see this is basically the same code that I was walking you through, right? And you can also see the graph, how the lineage of the graph looks like in Airflow. So you will see we have start here, generate and upload, copy to Redshift, and everything is looking green. Lovely. Okay, so now let's go and confirm if our data is actually uploaded. So let's go first to our packet in S3. This is where the data was supposed to be dropped. Let's refresh this. Lovely. Okay, so you can see now we have the CSV file here, and this is the name of the file, CDC order data, and the timestamp. You can also download this and basically scan how the data looks like. So I'm just going to open that, and this is how the data looks like, right, from the file. This is how the file looks like. You have your order ID going up to number 20, custom ID, order data, order date, status, and the rest of the information. Awesome. So this is how we wanted the data to look like, and we do have the data right here. Okay, you can also see the additional field, the total amount that was calculated in our code right here. Yeah, this one here. Total amount is calculating quantity and price. Sorry, the total amount is quantity times price. Okay, so we have the file written here. Now let's go to Redshift. Okay, so this table before was empty because it's writing to this staging schema and the order table. Now let's run it and see if the data is available. There we go. Okay, so you can see we have records available, and we have, okay, so looks like we had 60 of them, and I believe this is because there was a DAG that ran earlier. So what we need to do is we will actually truncate this table again. we'll just basically STG orders. Hold on, total rows is 60. Let's count that. Just make sure that we are seeing the right amount here. Yeah, 60, but it should not be 60, so it should be 20. I think there was already data in here, so I'm going to truncate this table. Okay, should be empty now, and what we'll do is we will come back to here, and I will also delete this file here. Right, so that's an append. Copy into is an append command, so if there was already data there, it's basically going to append the data to what is there. And I will show you in the next time when we do that video for DPT. It's going to make a lot more sense when we do that. In this case, I'm just going to run it once. I want to run it once, and we want to make sure that that data is uploaded successfully. When we are doing like transformations and DPT and things like that, we can simulate if you have incoming data and chain data, how we go about handling that data. Okay, so I'm going to go back here, and we are going to run this DAG again. So we're basically going to run this. It's basically going to do the same thing. It's going to generate the data, push it to S3, so we can see the generation is done. Upload, copy to Redshift is done. Okay, good. Everything is good, and we will refresh this here. Okay, this is our file, and now if you go to Redshift, we should have only 20 records. Okay, let's do that again. There we go. Okay, so we have 20 records now, and we can now do a quick check on this data. There we go. Okay, so we have 20 records: order ID, custom ID, the order date, the status, product ID, quantity, price, total amount. Yeah, so from the face value, everything looks good. Now, obviously, you know, if you are doing this in a real sense where you have real data coming in, real customer data coming in, then you want to have error handling in place and make sure that the data that you are receiving is accurate. But again, this is just a loading. This is basically the raw layer. This is your raw data, so we may not need to do any transformation at this point. So the transformation piece comes after you have loaded your data. So this is our staging layer, raw layer, which should be similar to what you have in your source. We are not doing any transformation, and this again, so this is ELT actually. So this is ELT where we are extracting our data, we are loading it, and the transformation happens after our data is in our data warehouse. So we have our data now in Redshift, and so the next thing that you will want to do is to transform this data. Okay, so in the coming video, we will be using DBT to transform this data in Redshift. Okay, so do stay tuned for that video. I will be going through that process, and we will be using this data in the transformation process. Okay guys, so that's what I wanted to show in this video. I quickly wanted to show you how you can use Airflow to orchestrate your ingestion process. Okay, so we used Airflow to ingest our data using Python. We landed that data to S3, and then we also copied the data to Redshift using Airflow. Okay, so everything was done within Airflow. So once we created our S3 packet and our table in Redshift, then we basically did everything else within Airflow. So you can see how powerful Airflow is. You can actually do a lot of things within Airflow to orchestrate your pipeline. So this is our pipeline, and we have it running daily now. So if this is now your data that's coming in daily or hourly or however many times, then you can basically come in and adjust the schedule, right? So you can come here and update the schedule and then have it actively running, and then from here now you can monitor your data, you can monitor your pipeline, and anytime there's a problem, you'll get an error, it's going to retry itself, and if it fails, then you will get a notification that there's a failure, and you can go ahead and see what is the problem, and you can go ahead and fix it. Alright guys, so that's how you do it. That's how you use Airflow to orchestrate your pipeline. Of course, there are a lot of things that you can do with Airflow, and this is pretty much a very basic ETL pipeline. You can build a robust pipeline however way you want it, okay? But this is how Airflow works, and it's a very basic one. Alright guys, so this is what I had for you in this video. I will see you in the next video. Again, if you have not subscribed to the channel, please do subscribe, and if you found this video helpful, please give it a thumbs up. Alright guys, I will see you in the next time. Bye bye.